Hi everybody, welcome to another video in Pre-Calculus, section 1.4, library of functions and piecewise defined functions. So, once again, this is another review for what we should learn in course algebra. So we have the basic function, constant function, identity function f of x equal to x, parabola, which is the graph of square function, square root, cube root, that's the cube function, this is the cube root, absolute values, and reciprocal function. Right. So identity function x square, square root, cube root, that's the cube, and it said okay, cube root, absolute values, and reciprocal function. Right. Now, except for the constant function, all of the other function have the characteristic of go to the point 1 and 1. And then either except for those two, this is an even function, an odd function, even function, because we're talking about the symmetry, symmetric on the origin, odd, even. This one is, there's no symmetry here, so there's neither. That one is odd, that one's odd, that one's even, and this one's odd. Right. So just familiar with this function. Right. Now the focus on this section is the piecewise defined function. We'll get back to this in the next part of the section where we study about transformation. But for now, we'll study about piecewise defined function. So it is just an example. The first one is the greatest integer function. So when we have the function and we just round that to the integer that is less than it. So for example, and the notation is the bracket of that number. So the bracket of 2 meaning the greatest integer that is less than or equal to 2. Of course, that's going to be 2 itself. Next, 1.3. The greatest integer that is less than or equal to 1.3. Of course, 1 is less than 1.3. And that is all of those integers, that is the greatest number, right? 0, of course, less than 1.32, but 0 is less than 1. So we're going to take the greatest integer that is less than the number we have here. Right. So this is not a rounding function, it's not. Right. Negative 1.2. How do we do that? Right. Negative 1.2. What is the greatest integer that is less than negative 1.2? Right. Of course, if we have negative 1 in here, it's greater than that, and then negative 2. So according to the definition, we will take the greatest integers less than that number. Of course, that's going to be negative 2. Because that number is less than negative 1.2 and greatest of all of those integers. So it's negative 2. Of course, if we look at the graph, it is or sometimes called the step function is kind. So for 2 is 2, and then go up to that, up to 3, but not including 3. If it is 3 and more, that will be start from this point and up. So those are the function. So any numbers between 2 and 3, including 2 but not including 3, will give us 2, and so on. So that's just an example of a piecewise function we define for each piece of a function. Right. Now look at some other example. Let f of x be this function for f of 0, f of 1, and f of 2. So f of 0 now f of 0, we would check for the condition first. X less than 1 is 0 less than 1. The answer is yes. So when it's less f of 0, we're going to choose the top function because that's where x less than 1. That's what we use. So we just put 0 into it. And we have 2. Next, f of 1. F of 1, we're going to choose which function that satisfies the condition. So here we have equal to. If we put 1 in here, 1 greater than equal to 1, it will be true because it has the equal sign. So 1 is greater than equal to 1. So that check. So we're going to use the second part of the equation. Negative 2, 1 plus 1. Negative 2 plus 1 is negative 1. And then f of 2. F of 2, we're going to put 2 in this function because 2 is greater than equal to 1. So we're going to use this part. And that is negative 3. Right. Now let's graph this function. So first, let's graph this one. This is a graph of a line on a linear function. So to graph linear function, we need 2 points, 2 distinct points we define a line. So we just choose it's less than 1, right? So we can choose, first we have 0 already. When x equal to 0, y equal to 2, right? So that's good. X equal to 0, y equal to 2. And then we choose another number. Any number will work. But of course we choose a number that is less than 1. So we can choose negative 1. But I will choose negative 2 because negative 2 and 2, the number will come out nice and even. Right? If you put negative 2 in here, that gives us 2 times negative 2 is negative 1. Negative 1 plus 2 is 1. So there's another point there, negative 2 and 1. Right. And then we graph the other function. Of course, we have to choose a number greater than or equal to 1. We already did here 1 and 2. When x equal to 1, we put in this function, and negative 2 plus 1 is 1. I mean negative 1. And then put 2 in that. Negative 2 times 2 is negative 4, plus 1 is negative 3. So when x equal to 1, y is negative 1. And when x equal to 2, because we choose a number that is greater than 1 here, 2, we have negative 3. Right. Now the graph. Notice that this function only up to x equal to 1, but not including, so the graph will not pass that. So it will only up to this point. And it's not equal to, so I put an empty circle there. And the other graph, negative 2x plus 1. It will not x have to be greater than or equal to 1, so this is only on the right side of 1. So only have this part. So that is the graph of that piecewise function. If it is a line, we just need to choose 2 points, 2 distinct points, define a line. So that's what we have. Now, can we graph this on the calculator? Well, certainly we can. Right. Now, first we're going to graph 1/2 x, so we can just put 0.5x, which is 1/2, right? Plus 2. Of course, if we do that, it's not going to work, but of course, yeah, it's not going to work. Yeah, we want the piecewise function, right? By the way, let's go back to the standard Windows. Okay. Now, if we want the piecewise function, that's kind of nice and all, but it's not going to be perfect. The graph will not graph the empty circle or the solid dot. Right. What we can do here is, instead of 0.5, we will still enter 0.5. Let's put that in the parentheses. 0.5x plus 2. Now we will do this trick. We will divide by what? Now this is x less than 1, right? X. If we want to type less than, you see the text above the math button. Hit second and math. Second and math. And choose less than 1. Right? So that piece. Now the other piece, negative 2x plus 1 divided by x greater than or equal to, again, second test. Now when we graph it, we'll see the piecewise function, right? Now, why it works. Right. Now, of course, we have to see what is this. When we hit second test, you see test and logic. Oh, so what the math it does here is the logical math. So logical math, I mean, in terms of loosely speaking, it's just true and false. True will have the values of 1 and false have the values of 0. Now I can test real quick. Say 5 is 5 greater than 6. The answer is no. So the calculator will give us 0 because that's false. Now, is 5 greater than 2? The answer is yes. The answer, the calculator will give us 1 because it is true. Right, so if it's true, it is 1. If it is false, it will be 0. Now get back to this function. We divide by a logical statement here, right? Now, if this is true, this is equal to 1. If this statement is true, it will be 1. And of course, when we divide by 1, it is itself. Now, if it is false, it is equal to 0. We cannot divide by 0. So in that case, it's undefined. If it's undefined, it will not graph any points. It will only graph the point where it is defined. So we use this trick. When it is true, it will graph the function. When it is false, it will not graph the function. And we just divide by logical statement there. Right? So yeah, that's nice and all, but still, the graph did not give us an empty circle here and the solid dot there. But of course, that's why we have to do it by hand. Right. Talking about do it by hand. We have the piecewise function that have 3 pieces, more than 2. Like that, I recommend we do it by hand also, because to type this in the calculator, we actually have to type x greater than or equal to -2, and then x less than 0 with all of the parentheses. So that's too much. So we're not going to do that here. But I mean, if it is piecewise function and only have like greater than or less than, then certainly we can just divide by. That would be nice. Right, now this one. Let's graph that and determine the domain and then the range. Right, so first let's graph piece by piece. X squared minus 2. Well, this requires some transformation we will study in the next section, but for now let's just see what it looks like. We know x squared is the parabola, right? So x squared minus 2, the parabola that go down 2 units, but it only go from -2 to 0, right? So we will not have 0, and then we have only up to -2. So I go way too far here. So yeah, if you put -2 in here, -2 squared is 4 minus 2 is 2. If you put 0 in there, you have -2. So for that part, you have that portion of the graph. Next, from 0 to 4, it is a constant equal to 1. So from 0 to 4, not including the 4, but including the 0, we have this portion of the graph, the function equal to 1. And then after that, we have the square root when x greater than or equal to 4. So the square root is going to be like this. But it's only for x greater than or equal to 4. So we just have that part where x greater than or equal to 4, including x equal to 4. So we just have this part. Keep going. So that's what we have. So square root x squared minus 2 went from -2 to 0, and 1 from 0 to 4, and then square root when x go from 4 up. Right. So determine the domain. The domain, of course, we go from -2 to 0, and then from 0 to 4, and then from 4 on. So the domain will go from -2 to infinity. Right? We don't need the graph. We just look at this and we say -2 to 0 to 4, and then to infinity. Now we have the graph. Now use the graph to find the range. Well, the range is on the y values, right? The lowest point is -2, but not including the 2. And then just go up, and the arrow keep going. So this will keep increasing. So the y, there's no limit on the top. So we just say -2 to infinity. So that is the range of the function. Next we have this application problem. In spring of 2015, Song River project supply electricity to the residents in Arizona. $20 plus 11.48 cents per kilowatt hour for the first 700 kilowatt hour in a month and 1160 per kilowatt hour for all the usage over 700 in a month. So how that works. So what is the charge for using 500 kilowatt hour per month? So in that case, for 500, first of all, we have the charge of $20 flat. So it have to be $20 regardless of you using it or not. This is 500. 500 is less than 700. So in that case, we will use this rate. And then, of course, that's not. This is cent, right? So it could be 0. Because we have $20 plus, so this also have to be in terms of dollars. 0.1148 times 500. $20 plus 0.1148 times 500. That gives us 77.4. Of course, dollars. Right, so that's straightforward, right? Now, what is the charge for using 1900 kilowatt hour in a month? Now, first of all, there's two different rates, one of which is less than 700, less than or equal to 700, one of which is greater than 700. So, for the first $700 kilowatt hour, we have $20 plus that rate times 700. So at that rate, right? So yeah, I have that already. Just hit enter and change to 7. Right, $100 and 36 cents. Now, of course, we use 1900 kilowatt hour. So the first 700 we pay at that rate. The next, of course, we have to subtract the 1900 to 700. So we say for the next. So for the net 1200 kilowatt hour, we will pay at this rate. And we get 139.2. And the total, we have to add these two together. So yeah, highlight that number, highlight, hit enter, copy and paste, 239.56. So that's what we have. By the way, if your calculator cannot do the highlight, you can always hit second enter. That will give us the last entry, and then we can just change that. Right? So that's how it works. So if it is 700 or less, we use this rate and still have to pay $20 flat fee. If it is 7 more than 700, we use this rate, and then we have to add them up if it's more than that. Now, if C is the monthly charge, develop a model relating the, now we just write the function C, the cost, as a function of X. So, now the first part is easy. We know that we're going to pay $20. And then what's left? And then at the rate of 11.48 cents. If it is less than or equal to 700. Right. So if it's less than or equal to 700, we use that. Now, what happens when it's more? When it's more than 700, we still have to pay the first 700, right? We always have to pay that. Of course, we can use that number too, but let's just say we have 20 for 8 times 700. So if it is more than 700, the first 700 we have to pay at that rate and the flat fee. After that, what's left? What's left? What is over than 700? We will multiply by the rate of 11.60 cents if it is greater than 700. Yeah, of course we can draw like that. And also we already did this. This is 100.36. So we can rewrite this as it is 20 plus 0.1148x when x less than or equal to 700. And then that would be just 100.36 plus 0.1160 times x minus 700 when x greater than 700. Right. So that is the piecewise function to represent this model. Right. Yes, as mentioned before, in this section we only focus on the piecewise function. So we do some example there. And about the basic function, we will revisit this in the next section. So I stop the video here. Thank you for watching and see you in another video in pre-calculus.